Afternoon, everyone. I almost said good morning. Welcome. Thanks for signing on time and for joining us today. I'm going to start with the introductions, of which I know many of you have heard. Thanks for your patience as I run through them again. It's great to have you here again today. For those of you who don't know me, perhaps this is your first CRED talk with us in this series. My name is Haley Ross, and I work with the Columbia Mountains Institute of Applied Ecology as their executive director, and I'm helping to organize this series. So I'm here to welcome you today. And I want to tell you a little bit about the CRED Talk series. So this series is focused on the theme of climate disruption in the Upper Columbia Basin. We've welcomed 8 scientists to join us today, over the series to address projected impacts, potential for adaptation, and what we might do with ecosystems that may in fact contribute to mitigation. If you're in attendance today, you've undoubtedly seen a number of the talks that have already taken place, and you'll be interested to know that there is just one more after this one. If you're reviewing the recording, I encourage you to go to the event webpage, which you can find at our website, cmiae.org, and have a look at all the talks that are featured in this series, because collectively they are telling a much bigger story, of which I'm sure you'll be interested to learn more about. Today we'll be hearing from Dr. Mike Flannigan, who I'll introduce in more detail in just a moment. But before I do, I want to start with some thank yous. So a big thank you first to the Columbia Basin Trust for the seed funding that helped us to get this project off the ground. Thank you for helping us there, as you have in past seasons as well. We're grateful. The series is also generously supported by all of you. So it's not lost on me the significance of that. I just want to thank you again for your donations to the series. It significantly helps with the production costs, and it secures our ability to continue on with the series in the future. And anyone who's recording or reviewing the recordings and is sending in donations, of which there are some of you, I want to extend a thanks to you as well. So before we get going any further, I just want to pause for a moment and acknowledge and honor the First Nations on whose traditional territory I broadcast from today in Revelstoke, BC. So that is the Sinixt, the Tnaha, the Secwepemc, and the Silks. So I'm going to open up my chat box here. And what I would like to do is welcome you to make your own acknowledgements. So please open up your chat box. You'll find that at the bottom of your screen. If you put your mouse at the bottom of the screen, you will see a control panel pop up. You can click on chat, and that will open a chat box, as I just said. And I invite you to introduce yourself and share your own land acknowledgement. I know a number of you have done this many times as the series has progressing, but I don't think it's something that we can do too much of. So I'll let you proceed with that. I don't see any popping up just yet, but I'm sure they'll come. And as those come in, I'm going to take this opportunity to tell you a little bit about your host organization, CMI, the Columbia Mountains Institute of Applied Ecology. So CMI is a nonprofit society and an association for people working in the various fields of ecology. Our home range is southern British Columbia, Canada, of course, but increasingly we see membership from across BC into Alberta, the Yukon, and the Northwest Territories. I see some of those acknowledgements coming in now. Thanks for doing that. One of the main things that CMI does is provide professional development opportunities. So of course, those come in the form of webinars like this. We also organize conferences, workshops, courses, and that sort of thing. For examples of the types of events that we do, of course, refer to our website, cmiae.org. You can check out our homepage. I've recently put up 3 new courses, so you might want to check those out, or you could go to the past events section and have a look at the sorts of events that we have done in the past. There are, of course, a number of resources associated with those larger events, such as proceedings documents and recordings from events such as this. Okay, so I'm going to leave that there, and I'm going to transition now to just a bit of a Zoom orientation. I think that we're all pretty much in the groove now, but we don't want to leave anybody behind. So just in case, some Zoom related announcements. So first off, this webinar is being recorded, and as I said, the recording will be posted to our event webpage. and you are free to share that with your network. We are hosting this event in the webinar format, so that means that all of you have had your video and your audio disabled. If you would like to have your audio enabled at the end to ask a question, just use your raised hand icon at the bottom. So again, if you bring your mouse to the bottom part of your screen, you'll see a little hand there. You can click on that. And in the attendee list, we'll see that somebody has their hand up, and we'll take that as an indication that you would like to speak. If you change your mind or you don't need to get our attention in that way anymore, you can just click on that raised hand again to lower it. If you would like to get in touch with the organizing team behind the scenes here, you can send a direct chat to us in that same chat box that we already used where you sent messages to everyone. You can use your drop-down menu and you can send a message to hosts and panelists, or you can send it to everyone, as most of you did. I do see that some of your acknowledgements came to just hosts and panelists. So if you're not seeing it on your end, that's because it came to us and not the whole group. So just something to pay attention to there. So I wanted to just note that although the chat is there and available, this is a really great place to share resources, for example. We're not going to use the chat for our questions. So if you have a question that you would like to ask Mike at the end of his presentation, we'll be holding questions to the end. We encourage you to put it into the Q&A function. So again, if you look at the control panel at the bottom of your screen, there's a little Q&A box that you can answer. I just opened mine up, and I can see that we already have a sample question there from Marc-Andre. Thanks for doing that. He says, which is faster, a centipede or a millipede? Gosh, I have no idea. But we have a couple people who are giving a thumbs up on that question there, which is giving us a signal that other people want to hear the answer to that question. Anyways, this is just a bit of a simulation on how we're going to use the Q&A. We have the upvote feature enabled. So if somebody asks a question that you would like to hear the answer to as well, click that thumbs up. And when I am relaying the questions at the end, I'll know to go to the questions with the most upvotes. It'll be ordered in that way on my end of things. So that's where we'll put the questions. Feel free to add your questions in there as the talk is progressing. I don't think it'll be distracting to Mike, but we won't relay them to him until the end. Okay, I think that's it for that. Now, the moment you've all been waiting for. So right now, I would like to welcome and introduce Dr. Mike Flannigan, who is going to present climate change and wildfires in BC. What does the future hold? So Mike Flannigan is a research chair of predictive services, emergency management, and fire science at Thompson Rivers University, and a scientific director of the Canadian Partnership for Wildland Fire Science. He has been studying fire and weather and/or climate interactions, including potential impact of climate change, lightning-ignited fires for over 40 years. He has a great deal of experience. He's well known in the world of fire, and we're really lucky to have him here today. So Mike, thanks so much for taking time to share your information with us. I'll hand it over to you.
My pleasure, Haley. I'm just going to share my screen. And while I do that, I just want to acknowledge I'm joining you from Kamloops. And that's...
I can see your email.
I clicked on the wrong, I am sorry. Let's try this again. Yes, okay. Hopefully that's a lot better than my boring email. I have a friend who hates email. I said, why do you hate email? He says, because it means more work for me. He was right. So.
Yep, I can see your PowerPoint. It's just not in, there you go.
Yep, it's coming. Hopefully it's coming. Oh, man. So maybe I'll do my acknowledgement while we try and figure out what's, oh, I know what I did. I thought I said from the beginning, but obviously I did not. Lost problems. So I am joining you from Kamloops, which is a traditional and unceded territory of the Algonquin people. I'm glad to be here, and I'm going to talk to you about fire. I'm a fire guy, and climate change. And what does the future hold? I don't have a crystal ball, but there are lots of indicators of what the future may be like. So let's take a stroll down the fire lane here and see what's going on. And for you who are wondering what that picture is, that's the Verdant fire just off the Rocky Mountain Trench in 2017. You can see it's quite an active fire. So I'm going to be talking today about fire in BC and Canada, climate change, impacts of climate change on wildfire, and briefly, what can we do about this, if anything? Well, we can. Okay. So many of you are joining from British Columbia. I don't have to remind you about 2021 and what a year it was, but first came the heat dome, heat event, record-breaking. The forecasts were really quite good. As a matter of fact, it was even more extreme than what the forecasts were saying. Record-breaking temperatures, unfortunately, led to the fires, and the town of Lytton burned down on June 30th after breaking the all-time record high for Canada, 49.6 degrees. For context, the previous record was 45 degrees. So a significant event, heat, fires, smoke, the bottom picture. You can see my mouse, hopefully you can. You see the valleys, all filled with smoke, but that's where most people live, in those smoky environments, and it persisted much of the summer. And then came the floods in November, mudslides, debris slides, and recently burned areas are more likely to flood and have debris flows, mudslides. They're not the cause, but the likelihood increases in recently burned areas, especially in areas of significant topography. This image slide is from Bowman et al. 2020, and I like this. I show it in pretty well every talk I give now, because it just shows the interactions of fire. It's not just with forests and grasslands. It impacts the atmosphere, the cryosphere, the hydrosphere through various processes that are, a lot of them are captured in this diagram. So I'd like to show you that the role fire plays in our Earth system, our climate system, is in some areas very significant. So, you know, in Canada, we burn just around 2.8 million hectares. You know, if you look at the last 10 years, on average, that's half the size of Nova Scotia. And it's doubled since the early 70s. And my colleagues and I attribute this to human-caused climate change, largely attributable to human-caused. There are some land use changes that play a role too. BC, we're averaging about 1,300 fires burning 350,000 hectares, and that's gone up a lot in the last decade. And the bottom graph in the bottom left there, you know, 2017, 2018, 2021, these are the top 3 years have occurred in the last 5 years since our records from 1950. But area burns an easy metric for us to measure, but impact's the one that's the most important. And I think 2021 was the most impactful year with the fatalities, loss of structures. Yeah, it was a very significant year. Many of these fires are what we call crown fires. So fires start on the surface, whether it's a grassland or a forest. You know, forest, it can reach up to the tops of the trees, the crowns of the trees, thus the term crown fires, and big flames, high intensity, difficult to impossible to extinguish. In Canada, as well as British Columbia, it's pretty close to 50-50 in terms of fire starts, lightning and humans. So if you look at the trend, human-caused fires are decreasing, and so is their area burn. Recall I mentioned our area burns doubled. That's because lightning fires are the reason for this. We're seeing a lot more lightning fires, and this trend is probably going to continue. You know, there's a few take-home messages from my talk today, and here's one of them. extremes drive the fire world. The tail wags the dog. And in Canada, 3% of our fires burn, 97% of our area burned. And these happen on a few critical days of extreme fire weather. So an average summer day usually isn't a problem for fire management. It's those hot, dry, windy days, like June 30th last year. Those are the problem days. Western United States, for context, 1% of the fires burn, 99% of the area burned. So it gets even more extreme, but extremes drive our world. So here's just a map of Canada showing decades of area burned by decade. And you can see BC was pretty quiet to the reds until the recent period. And this doesn't have 2021 on there yet as well. So yeah, there's a lot of fire, and it goes from sea to sea to sea. And here's evacuations. And once again, they go from sea to sea to sea, but you'll notice there's a lot in British Columbia. And, evacuations disproportionately affect, remote and Indigenous communities. So, they're the most vulnerable to evacuations. So maps of, there's something what we call in the fire business, the wild and urban interface. And, acreages, people live, at the fringe of cities and towns and communities in the woods, and people love it. There's trees and wildlife and things like that. But there's also industrial interface and infrastructure interface. And so you see the map of Canada on the left. On the right, you see example for BC with industrial interface. And you can see there's a lot of values on the landscape. And, that's something that fire management needs to protect communities as well as critical infrastructure. So in Canada, we're fortunate. We have among the best fire management agencies in the world, and BC's among the best in Canada. We use something called the Canadian Forest Fire Danger Rating System, and parts of it, like the FWI, Fire Weather Index, are the de facto global standard for fire weather indexes in the world. However, parts of the system are 40 to 50 years old, and it's in need of an update. Demands have changed, data availability has changed, and so they're in the process of updating the Canadian Forest Fire Danger Rating System, and should be coming out in the next few years. Fire management is challenging, it's becoming more challenging. Climate change, increased demands, and you see a picture of Smokey there. And I have this comic book in my office, and I think it's from the 50s. Smokey has two messages. One of them is only you can prevent forest fire. And for human cause prevention, that's a great message. But the other message is that gives the impression that fire is bad. Okay, fire is not bad. Fire is natural. It's Mother Nature at work. And fires are an essential part of many of our Canadian forests. So, it's a valued statement, and we need more fire when and where possible in the landscape, rather than trying to extinguish all fires, which has been the traditional approach. But things are changing. So we spend 900 million, $1 billion every year. These expenditures are going up faster than the rate of area burned increases. So yeah, so this is suggesting that maybe status quo is no longer an option. Just for context, 2021 fire season in British Columbia, I haven't seen the final numbers, but I think it's around $650 million, $670 million. These are direct costs. These aren't insurable losses and things like that. So this is significant. And on the left, you see a graph, and it ends at 2016, 2017 was estimated. It's not because I'm too lazy to update the graph. It's the federal government hasn't updated their database. But you can see that even that last column isn't a full decade, but it's already head and shoulders above other decades. And this trend is going to continue, unfortunately. So fire is like real estate, location, location, location. You know, that fire in Fort McMurray, it started 100 kilometers to the east. It wouldn't have been the cost of this disaster in Canadian history. It might have made this paper in Saskatoon, the Star of Phoenix, saying poor air quality due to northern Saskatchewan fires or something like that. But it didn't start there. It started right beside Fort McMurray, and a chunk of town burned down. Every year we hear fire problems all around the world, and you know, last year BC, Saskatchewan, Manitoba, Northwestern Ontario had the most area burn that they've ever had. Of course, California every year, and this is one of the things that scares me, keeps me up at night, is British Columbia going to become more like California with respect to the fire season, which is, yeah. Siberia, Turkey, Greece, Algeria. There was numerous fatalities in Algeria this year from fires. Globally, smoke-related fatalities are closer to 340,000 from a paper almost 10 years ago. And primarily Southeast Asia, but per capita, Canada is actually fairly high. There's estimates about 2,500 people die every year in Canada due to wildland fire smoke. And of course, air quality. There's a graph there at the bottom. While I was in Edmonton, and you can barely see across the street due to wildland fire smoke, and we had the worst air quality on the planet for larger urban centers for a number of days because of smoke from, you know, smoke from British Columbia about 800 kilometers away. And that's the thing about smoke, is it can travel long distances. So even if you're downtown Toronto, your place isn't going to burn down from all the fire, but you can be smoked out for days or weeks from fires, you know, in northern Ontario or Quebec. So smoke is a real issue. Here's a slide, and this is from the 2020 fire season. And the gray is the smoke. You can see my mouse, and you can see it being sucked into a low pressure system. You see that spiral counterclockwise. It's a low pressure system in the northern hemisphere. And then there's smoke being sucked up into a low pressure in the east, and down the subtropical low pressure system. So long distances can circle the globe multiple times sometimes. So here's another take-home message. There'll be 2 or 3 of these, and you know, this is the recipe for fire, and it's a simple recipe. There's only 3 ingredients, and this applies whether you're in California or Australia or the Arctic or the Amazon or British Columbia. Fuel, that's vegetation, the stuff that burns, we would call it fuel. How much you have, what type it is. Conifers are much more flammable than broadleaf trees. Probably most critical is fuel moisture. How dry is that fuel? Ignition, we've talked about humans and lightnings, aspects of fire. Weather, hot, dry, windy, that was extreme conditions. You have all 3, you now have a fire. The fuel is fairly static, whereas weather is dynamic. Fuel is static, except for the moisture does change with the weather. So let's talk briefly about climate change. You know, when I give classes, I often say, how hot is the sun? And you know, hopefully someone says, about 6,000 degrees. I said, what does that mean in terms of wavelength? And hopefully they say, oh, it means most energy comes as shorter wavelengths. Earth is about just under 300 degrees Kelvin. It emits most of its energy as long waves. Certain constituents of our atmosphere are what called greenhouse gases that are more or less transparent to short wavelengths and more or less opaque to longer wavelengths. So it traps the heat, and it's like putting another blanket in your bed on a cold winter's night. It keeps you warmer. And you know, this greenhouse effect has been going on since day one, essentially, and it keeps us warmer. And as a matter of fact, you know, about 30 degrees warmer than we otherwise would be. So without that greenhouse effect, we'd be really much a colder planet. So we're Goldilocks here. Mars is too cold, and Venus is way too hot. We're just right. All right. However, now human activities are increasing some of these greenhouse gases. And, you know, carbon dioxide is one of them. We have records going back hundreds of thousands of years for carbon dioxide from ice cores in Antarctica and Greenland. There's trapped air bubbles, and you can measure how much carbon dioxide there is. And it was pre-industrial between 270 to 280 parts per million. And then the Industrial Revolution, burning of fossil fuels, it goes up and up and up. And here is a graph from Mauna Loa, and that's on the Big Island of Hawaii, and it's the longest record we have. My understanding it started in the late 50s, as you can see, and we're approaching 420 parts per million now. Remember, 270, 280 was pre-industrial, and no human prior to this current generation has seen anything close to this. The last time the Earth had carbon dioxide levels at this point was 3.5 to 4 million years ago. Looking at the global temperatures, we're going up and up and up. And, super El Niños or El Niños are typically much warmer years. And, but we're finding, like 2020 was still very close. It wasn't an El Nino year. This year wasn't an El Nino year, or 2021 wasn't. And it comes in fifth or sixth place, depending on which data set you use. So here's what the year 2021 looked like relative, and those are in degrees Celsius, compared to the 1951 to 1980 baseline. And you see it's a much warmer place. There are areas with no change or even cooling, Antarctica and some of the ocean locations. But being a northern, high latitude northern country, the warming isn't equal, and it's warming much more at high northern latitudes. And this is just from 2021, but this is consistent with what the models suggest the future will look like, is high northern latitudes will see a lot more warming. So there's a couple of things here. First is the graph showing the global monthly temperature anomalies, and compared to the 51 to 80 baseline. And the last time the globe had a below normal month was December 1984. So that's over 400 months of above normal temperatures. I think there's a clear trend here. I gave my first talk on climate change in 1985, okay? And been studying climate change and fire ever since. The inset map there is January 2022, and you can see it's almost a degree Celsius warmer than the 51 to 80 baseline, and you can see significant warming in parts of the planet. It's actually the warmest non-El Nino January on record. So this warming is continuing, and this is bad news for fire, and I'll explain that soon. So here is an animation of observations, and this one's in degrees F. I'm upgrading to a degree C one shortly, but those are degrees Fahrenheit top left. Years are shown near the bottom center, and you can see that blues are below normal to the baseline, reds are above normal. And you can see by the late 70s, things start to change, and we become a much warmer planet, especially high northern latitudes. So this is from Canada's Changing Climate Report, and chapter 4 is on temperature and precipitation. Canada's warming at twice the rate of the rest of the world, and the northern areas at 3 times the rate of the rest of the world. So we are warming, and you see most of the warming is not spread equally over Canada. It's mostly in the west and the north. So last week I did not catch Colin's talk live, but fortunately it was posted on the website yesterday or the day before, and I was able to watch it. And I learned a lot about SSPs. Thanks, Colin, it really helped. If this is CMIP 6, there'll probably be a CMIP 7, and these models are models. They're not perfect, but they're getting better. And we're going to see warming depending on how we get our global act together. And the greatest increases will be at high northern latitudes, especially in winter. You know, eventually, if I had more time, I'd talk about sea ice, Arctic sea ice, which would become seasonally ice-free at some point this century. Some people say 2050, some people say earlier. You know, our models have been around for a while, and they've done a really good job at temperature. Precipitation is a different story, but temperature, they've done really good, but impacts are much more severe than expected. I'm talking about flooding, and I'm talking about fire. Like fires we're seeing in BC and arguably California wasn't something I was expecting until the 2040s, maybe 2050s, and we're seeing them now, okay? So, you know, a lot of our estimates of the future may be conservative in terms of impact. GCMs, we expect more extreme weather, and this is bad news for fires, floods, and other hazards as well. So COP26 was in Glasgow not that long ago. I was disappointed personally by what happened. And if we honor the commitments thus far, and I'm looking for my mouse, and I can't find it, but oh, there he is. Okay, it's hard, way on the way, it's hard. You know, if we honor the agreements we've made globally, we'll be near this blue line, maybe just give or take right around the center blue line, which is still 3 degrees warming, which is way too much, okay? The IPCC report just came out this week, and they're moving towards degrees, you know, increased warming rather than SSPs per se. But the problem is that many countries don't honor their agreements, and unfortunately Canada is one of them. We promised the sky and delivered very little thus far, and so it's really quite disappointing. Hopefully things change and we get our act together. So here's another animation, and hopefully this works, and set of observations. This one's Canadian, so this is degrees Celsius. On the bottom scale, you can see it, red's warmer than normal, blues, if you find some, are below normal. Yes, 15 degrees Celsius. Wow, that's oh, this is scary. This is the old RCP, which is CNET 5, but you get the impression that warming is widespread and significant. You know, this will be a problem. And the things that is another scary thing is, even if we got our act together, and even if we had a magic wand that said no more greenhouse gas emissions from people, done, okay? We'll continue to warm for 20, 30 years, perhaps longer, because there's lags in our climate system, particularly ocean currents. Deep ocean currents have time lags of up to 1,000 years. So we are going to continue to warm. This is work done a long time ago, 17 years ago, and looked at how much more area burned we'll see. So this one came up with about a doubling of area burned by the end of the century. And since then, there's been many papers published, and much more significant increases in most of them, 4 to 5 times, some 7, some over 10 times increase. And you go 4 to 5, this is crazy town. No, it's not crazy town. The American West has increased by a factor 4 their area burned since the 1970s. California, depending on what endpoints you use, either by a factor of 5 or a factor of 8. So we're already, our neighbors to the south are already there, and we're heading in that direction. So the work I've done, my colleagues and others have done, we find the warmer it gets, the more fire you see. And you say, why is temperature so important? And here I'm not talking individual fire like the Lytton fire. I'm talking about fire over a larger area, like British Columbia, for a longer period of time, a year or 10 years, a decade. And there's 3 reasons. Aside, fire people love 3s. Everything has to be broken down to 3. So fire seasons are longer, and that's already happening in parts of Canada. I was just doing some air reviews in Alberta. Their fire season just started March 1st. It used to start April 1st, but they've been observing earlier fire starts, so they start preparing earlier. And this trend will continue. The the warmer it gets, the more lightning we see. Studies in the States suggest for every degree of warming, you see about a 12% increase in lightning activity. So if we get 4 or 5 degrees warming, we could see significant increases in lightning activity. And recall that the increases we're seeing in fire activity are due to lightning caused fires. And the third reason is probably the most important is the warmer it gets, the drier our fuels get, unless there's increases in precipitation. But barring that, as the temperature warms, the atmosphere's ability to suck moisture out of the fuels, and here I'm talking about the dead fuels, think of the forest floor, grass, needles, leaves, it becomes very efficient, non-linear, almost exponential increase as the temperature warms. Drier fuels, okay, here's another take home. Drier fuels means it's easier for fires to start, easier for fires to spread, and it means more fuels available to burn, which leads to those higher intensity fires that are difficult to impossible to extinguish. This is recent work by Push Jane with Canadian Forest Service and others, came out in November, if I recall, looking at extreme fire weather, because, I argue that extremes drive the fire world. And it looked at trends in the fire weather index, 95th percentile. Fire weather index is an indicator of the intensity of the fire. The ISI, initial spread index, 95th percentile, is an indication of how fast the fire might spread. And VPD is a vapor pressure deficit, and that's an indication of how efficient that atmosphere is at sucking the moisture out of the fuel. And you can see that the trends in these extremes is increasing, and particularly in the American Southwest, but it does extend into British Columbia and Alberta. And yeah, look out. These are observations. And the graph on the right shows these same 3 variables for global flammable area, and the top 8 of the top 10 years have occurred in the last decade, and the trend is quite stark. Okay, so we're seeing more extremes already, and the more extremes we see, the more extreme fire weather, fire activity we will see. This is work done by the American National Assessment, and many models have more trouble with precipitation than temperature. But, as we warm, we expect much of Canada to see more precipitation, but it's not equally divided according to season, and particularly summers in places like British Columbia and the Southern Boreal appear to be, or indications are they'll be drier than normal. So warmer than normal, drier than normal, this is a recipe for more fire. This is a recent study that came out online last year, but just came out in print this week or last week, I believe. And it's looking at fine fuel moisture. So that grass, needles, leaves, that litter, what's the trend of seeing days of moisture content of about 10% or less? And you can see the trend is, and it's kind of similar to what I was showing about the extreme fire weather, and even bigger brush though, because this is global. But you see, once again, British Columbia and parts of the Boreal and Alberta and other places are showing up as well. So we're seeing drier fuels, which would fit into the increase in area burn that we're seeing. So escape fires. So that's the issue. Our fire management agencies are very good at putting fires out, but if they escape, and once they become big and they're high intensity fires, it's hot, dry, and windy, and the fuels are conifers, you now have a big problem. And so work done by Justin Perdue and Mike Watton suggests that there could be significant increases in area burn because climate change will overwhelm our fire management capacity. Escape fires, these are tied to the extremes. If we see more days with strong winds, it means that these fires can be faster spreading, more intense, more likely to be escape fires. And it's just shifting this distribution. And this graphic just shows an example of this distribution from the past, where the probability was 1/60, but as the distribution shifts, it now becomes 1/5. So if it's a physical threshold like fuel moisture, that's a critical event for fire spreading and starting, this is significant. So what can we do? Okay, first, there should be national risk assessments done for all hazards, including fire. I see this as a federal responsibility and needs to be done. Every community needs an emergency management plan. The larger communities can afford it. A lot of these smaller communities don't have the resources. Emergency management includes prevention, mitigation, preparedness, response, recovery. Some people include review. Fire management is really good at response. We're not bad at preparedness. There's room for improvement, but prevention and mitigation, yes, we can do more. Ounce of prevention is worth a pound of cure. We should make more use of Indigenous and local knowledge. Program called Fire Smart Canada, 7 principles for making communities more fire resilient, as well as your homes. Fuel management, that's one of the principles that should be done. Thinning, prescribed burning, grazing, carbon management, all has to be taken into account. We should focus on where the values are, which is, communities owned. Things like sprinklers are very effective, but you need independent power, independent water, because when fire enters a community, that's one of the first things that goes is power and water. Building materials, community planning, green grass, very effective fire breaks. So you should plan your communities with your soccer pitches, the edge of the community, golf courses, etc. A lot of the people are being evacuated and the community does not burn down. So we should explore using emergency shelters, fireproof shelters, cooling centers. I think it's a multi-purpose building, could be a town hall, arena. Instead of the social cost of evacuations high, as well as the economic cost. So let's throw a wild card in here. It's called the jet stream, and the jet stream, really dictates where our weather systems go, our high pressures, our low systems, and it gets its energy from the temperature difference between the equator and the Arctic in the northern hemisphere. Remember, the Arctic's warming at 3 times the rate of the equatorial areas, so that difference is getting smaller. So instead of a fast flowing river with low pressures coming through every 3 to 5 days, bringing rain, and I'll tell you, if it rains every 3 to 5 days, we won't have a fire problem. Instead, you get a lazy pattern, slower, like a lazy river with eddies and whirlpools, and you get stagnation, and you can get these conditions called blocking ridges, sometimes called omega block because they look like the Greek letter omega. What's happening there is air sinking, warming, and drying. And if it stays there for 7 or 10 days or longer, it dries out all the fuels. So everything's primed for a fire event. And that's exactly what happened with the heat event in 2021. And fire researchers have known this for 50 or 60 years. But these ridges seem to be getting stronger and more long lasting. Now, is it because of this lazy jet stream? The jury's still out. There's lots of research, but because of the warming conditions, this is what currently is driving the increases in these ridges. And conversely, where the troughs or lows are, you get rain. If it stagnates, you keep getting rain in the same place, you get the flooding. So that's more extremes of both ends of the spectrum. Pyrocumulonimbus, fire-generated thunderstorms, and we had a lot of them in 2021. North America, over 50. Never seen that many in a year. It's a short period of record, but we could be seeing a lot more of them. And in British Columbia, we saw some that generated thousands of lightning strikes and tens of fires downwind. I've never seen such an active pyrocumulonimbus. We're also seeing more nighttime burning, which is a real concern because we used to get the break at night, and that seems to be disappearing. There's a recent paper out on that topic. And last year was a strange year because there was a couple of days in July where I saw active fires all the way from Quebec to the Yukon. And I'd never seen such a wide swath of very active fire. And here's an animation from June 30th. And you can see these are pyroCPs. The gray is the smoke, and then you see the white, that's cloud. The combustion process, of course, is hot air, but also moisture is a byproduct of combustion. So it lifts, it's your grade 3 water cycle. It's lifted, cools, condenses for clouds, and eventually thunder and lightning, and away we go. So and this is from a geostationary satellite about 36,000 kilometers above the Earth. It just sits there and rotates the same speed as the Earth. It takes a picture, in this case, every 10 minutes. And that's what you're seeing with this animation. A couple of recent reports out. I didn't put the IPCC one out there, but there's the UN report, spreading like wildfires global, suggesting a 50% increase in fire activity. I think that's conservative, but it does suggest more emphasis on prevention mitigation. Building a resilient Canada, there's disaster risk reduction, and there's climate change adaptation. There have basically been two silos, but to plan for anything in the future, whether it's a highway or a dam, we have to consider the changing climate or it will fail. So I'm going to wrap up to leave some time for questions. We're going to see more fire in the future, and we have to adapt. Our fire management society has to adapt to this new reality. Some people say new normal. I don't like that term because normal sounds like a steady state. We're on a trajectory and it's downhill, and so that's the reality. So we're entering the known unknowns. We can't just use our past experience to guide us to the future, because there may be no analog for what we're dealing with. High intensity fires occurring outside of what we normally expect. Our normal busy season in British Columbia and the Columbia Basin is kind of the latter half of July into August. And here last year we had active fire in June. Okay, and that stretch may only increase. Fire and society will continue to interact. We have to learn to live with fire and smoke, and I know that's not easy. And there are ways we can deal with it. Fire is a multifaceted issue, and we'll need multi-pronged solutions or approaches to deal with it. Close with Canada wildfire. I probably don't have time to get much into Canada wildfire. Website, Twitter, Instagram, YouTube, check it out. Check out the website, some of the sponsors for some of the research I do. And yes, another pyro cumulonimbus, and this one's from the Northwest Territories. Thank you for your attention. I'm going to stop sharing and try to answer questions.
Whew, rapid fire. Thank you very much. I think I said in my email that I was equal parts looking forward to your talk and equal parts dreading, and I think that stands as accurate. The old firefighter in me is intrigued and excited by what you share, but the mother in me is terrified. Anyways, thanks again for sharing. I know that you had tons of other information that you could potentially share with us. Maybe we'll delve into that a bit in the questions. There are some questions coming through. So just a quick recap, if anybody has any questions that they would like to ask, we're encouraging you to open up your Q&A, to type your questions into that Q&A. I should note that if for whatever reason you would like to ask your question anonymously, there is a drop-down menu that allows you to change your setting there, so you can ask anonymously if you would like to. And what I'll do is I will relay the questions to Mike in order of popularity. So again, feel free to use those thumbs up, and that'll help direct us. Okay, so our first question here comes from Marc-Andre, and he says, how much water is used of natural resources such as lakes and rivers to put out fires, i.e. example, planes and helicopters, sprinklers, etc. And have the effects been documented or measured, if significant? Does removing such amount of water actually make things worse?
So this would probably be best answered by the BC Wildfire Service, but I'll take a stab. Okay, so retardant is being used a lot more than in the past, so that uses no water. Okay, it's, if you see those either falling from the sky, usually red powder. If you're walking in the woods, you see the red powder, that's the retardant. And then environmental impacts of the retardant may be a really good question to address. The amount of water we use is probably insignificant. Sometimes it does affect wildlife. I've heard of skimmers bringing in turtles and things like that, unfortunately. But generally, no, I don't think it's a big problem at all.
Okay, thanks. So next question comes from Richard Johnson. Were there any fires in 2021 that were slowed or stopped by wildfire risk reduction work?
Okay, interesting question. So unfortunately, a number of structures were lost last year. If we're talking about 2021 in British Columbia as opposed to other locations, the poster child is Logan Lake, and there was a lot of work done at Logan Lake, and I think it did have an impact. There was also a wind shift too, so it's, were they good or were they fortunate? I think a combination of both. Okay. So in an ideal world, you do fuel treatments, vegetation management, so the fire is less intense. It doesn't stop the fire, but it's less intense, so fire management can put it out. The problem is that if there's so many fires in the landscape, you may not have enough resources to even get to the fire, even though it's lower intensity, so it can still get into town. And it's really challenging because the way a fire typically enters a community is through burning embers. And these embers can travel 2 kilometers. I've heard anecdotes of 5 kilometers in British Columbia. So this is a real problem because you can't treat 2 kilometers around the community. So there's always going to be this chance of this rain of burning embers. And that's why things like Fire Smart and having non-flammable material right against your house, fire is opportunistic. It's probing. It's just trying to find a spot. And once it enters a community, then it can spread from structure to structure. So it's really challenging. But Logan Lake is an example of what people say where it was successful. And the strategy is intuitive, it's logical, and will help, but doesn't make our communities fireproof. I guess that's the bottom line, is there'll always be risk.
Fair enough. Okay, great. Thanks for tackling that one. Next question comes from Ross. He says, hi, Dr. Flannigan. Could you speak a little bit about vegetation response to climate change? Is it possible that with improved forest management, we could see less severe, maybe more frequent wildfires in some regions with the expansion of fire-resistant species in BC and fire-maintained ecosystems? Or does extreme fire weather drastically overshadow these potential shifts?
So if fire continues to increase, trees will not be able to regenerate, whether it's sexually or asexually, seeds versus suckering. Okay, and then you get to a grassland system, and I'm in Kamloops, and there's grass / sage and non-tree montanes. So that doesn't mean we're not going to see fire, but we'll see probably more fire, and we get buffalo grass and things like that coming from the American Great Basin. Invasive promotes even more fire. So there'll always be fire as long as we have those 3 ingredients. If you have more broadleaf, it's likely you'll have less intense fires. But I do like to point out, I have colleagues who call aspen the asbestos forest. It's not. It does burn. It's not as flammable as conifers. Fort McMurray was surrounded by aspen, and look what happened to Fort McMurray. So it will help by having species that are more fire resistant. That's the term you use. So yes, it helps. But what happens is, at some point, if it gets so extreme, fuel is fuel is fuel. It will burn. And knowing exactly when that transition happens is hard to say. And things like vegetation treatments around communities is the maintenance aspect. If you treat it with thinning or prescribed burning, great. But how long is that effective for? 5 years, 10 years before you have to redo it? Anyway, just a few thoughts. Okay.
Yeah, okay. Question from Kyle. Could you speak to the ways in which our communities can adapt to having heavy smoke for extended periods of time?
Boy, that's a tough one. So first thing is, at the beginning of a smoke session, you keep your windows shut, you don't exercise or do physical labor outside, because smoke is composed of very fine particles, even smaller than PM 2.5. And the smaller the particle, the deeper they get into your lungs, so that's bad. Over a prolonged period, the air quality in your home can be worse than outdoors. So having air purification systems in your home, either through your furnace or in standalone, and I have now 2 of them because I'm living in Kamloops, these do help keep your filters clean, and that does help. And let's see, if did the question go with that? I'm not sure if I answered the entire question.
No, I think you answered it, but sorry, I dismissed it.
Well,
I should.
But I think having clean air shelters and cooling shelters, I believe Prince George had a clean air mall or something like that set up for last year, 2017, 2018, to get away from the smoke. But yeah, it's bad. And the more we know about wildfire smoke, the more we know how hazardous it is to human health.
Okay, great. This was one of our earlier questions, and from Becky, she says, oh, it just got bumped down, but is the figure smoke-related fatalities able to distinguish between wildfire smoke and cigarette smoke? If yes, can you elaborate?
Yeah, it's a study by Faye Johnston, and I can send you the paper, but it does distinguish wildfire smoke from other smoke.
Okay, great. A question from Carolyn. What percentage of large wildfires can be directly related to forest harvest, road building activities?
Directly in terms of ignition, it's a pretty minor role. It depends what part of the country you're in British Columbia, railways, power lines, campfires. Lightning's our biggest one in terms of area burned. In terms of impact, because human-caused fires are often close to communities, Lytton's still under investigation, so I can't use that as an example. But yeah, it's a fairly small player in the overall situation.
Okay, thanks. Okay, this question is from Tyne, and okay, actually, sorry, Nadine's just popped to the top, so we'll go with Nadine. Climate change research in the Columbia Basin suggests that there are climate refugia, such as north of Revelstoke. Can you speak to whether we are seeing these areas being more resilient to wildfire, or any other comments on refugia?
Yeah, refugia. So it depends. There's refugia that are persistent because they're sheltered, either wetlands or other characteristics, and there are random refugia just out of pure stochasticity, just randomness, rolling the dice. It didn't get burnt at a particular time and area. So these are important aspects. Are they lifeboats for wildlife and other species? Perhaps. But as the climate change continues, these refugia are going to be squeezed. And whether it's by fire or just by the actual, the temperatures and drought that we see with the future climate. So it's hard to say, but we should try and preserve them as best we can, if we can.
Okay, great, thanks. Okay, so Tyne, I was sort of laughing because I'm going to stumble over this word. Do pyrocumulus nimbus, I did it, clouds usually increase intensity of local fire or local strikes, or spread fire to new locations, strikes to neighboring areas? Are these clouds more likely in these extreme weather conditions?
So, increased intensity of local fire, local strikes. Yeah. The first pyrocumulus nimbus I reported was in Ontario in 1986, and it started a new fire, but it was just one new fire. Fort McMurray started 3 or 4 new fires. Sparks Lake started about 40 new fires. So we are seeing more of these. These are pretty uncommon to see that. Now, extreme weather, yes, these are typically, and was the real concern is, you know, we have something called the Canadian Forest Fire Danger Rating System, and it really wasn't designed for pyrocumulonimbus. And so our models may not work with with these extreme fire behavior situations. And yes, extreme conditions, the atmosphere is very conducive, the fire is very intense, and the fuels are very dry.
Okay, all right, sounds great. So we're 102. I see that there aren't any more questions in the Q&A, but I do see that one ended up in the chat. Do you want me, I read one more question in the chat? Yes, I agree. Okay, so let's grab this one in the chat here. So this comes from Mindy. What's the best thing people living in town and on forest interface can do to prevent wildfires destroying towns and homes, such as grass cutting, watering, plants, home construction, cladding, access to surrounding forest lands with wildfire season?
So work together as a community. Fire Smart BC is one place to start. Be prepared. Have a package ready to go with all your replaceables in case there is a fire. Yeah, I mean, I wouldn't recommend staying and defending unless you were really in a good situation and were very knowledgeable. Be aware of, you know, reports. I actually believe some places in fire risk areas should have sirens, okay? So that when there's evacuations, the sirens go off. They're used for tsunamis and they work really well, in addition to social media. I mean, building material, there's lots of things coming out now, checklists for new homes to make them more fire resilient, and check Fire Smart in terms of making your home, you know, keeping those flammable stuff away from your home, and that helps reduce the risk. But you got to work as a community together on this issue. Okay,
great, thanks. And I think that's Nadine. She points people to the resource, the Fire Smart BC resource, and that link is in the chat, which gives a bunch of guidance in this regard.
Thanks, Nadine.
Also, some funding looks like to help with, Okay, great. Thanks very much, everybody. I'm just going to conclude with some concluding words. Thanks for pulling up that slide, Nicole. So once again, thanks to the Columbia Basin Trust for your financial support. Thanks again to everyone who donated to the series, very much appreciated. A recording of this talk and all previous are located on the event webpage. You can find that at cmiae.org. And please share the recordings with your network. Once we get the last recording up, which is going to be next week's talk, we'll start promoting this series as a whole, and it would be really fabulous if we could get your support in getting this out into the world further. Next week for our final talk, we'll be welcoming Greg Utzig with Kootenai Nature Investigations and Kootenai Reliance. I'm sure many of you are familiar with Greg's work, but then again, I feel like he's understated, so maybe you're not. He's been given the Herculean task of wrapping up the series. So he's going to try to pull everything together and pull out some pieces that perhaps weren't addressed. Greg Utzig is, actually, I'm going to leave that for now for sake of brevity. So we'll meet next week, same day, same time, March 10th at 12 p.m. Pacific. And hopefully we'll see you there. Thanks everybody for joining us. And maybe Mike, just check out the chat because I'm sure there's some thanks to you showing up in there before we close off.
Okay.
Okay, thanks everybody.